Hey everybody, how you doing? Just kind of wanted to touch bases with you on a longer run video because I'm not entirely certain what's going on with the shorts, and you may have all been experiencing this as well. I was getting like tons of views, and now all of a sudden things are dropping off. And I'm getting notifications that they're having issues with this, they're having issues with that, and then they fixed the issue, or they said they fixed the issue, and I'm not seeing it. I don't know what's going on, but I wanted to kind of give you an update in a longer run video so that you know what's going on. And then we'll get to the long run video where I am constructing this part here, because you saw the part one. The part two is going to be getting everything together into one final unit. So as you can see, we have the two engines that are done here. We are waiting for 3 more of these motors and the ESCs. After that, since we have the lighting done on these, basically all the motor mounts are done and the heat sinks are cut. We're going to get those motors mounted, the ESCs mounted up through the body, and then to the carbon fiber rod stack, because those will be here, I think, tomorrow. So I can finish out the internals. And then I'm going to come over here and do to this engine, basically, what I did to the third engine. Now that light cycle you're seeing is cool. I may add it, but it's just something I'm doing to test with an ESC, and it's 5 amp BEC, or 5 volt BEC, to check to make sure that the lighting rig's working like it's supposed to, and before I attach it to the main system and then to the bus bar system that I have set up over inside the drone. So that was the whole idea behind all of that. I have some allergies that are killing me, so forgive me. So that's our next steps. At this point, engine 3 is done. I just have to, I'm waiting. Actually, we just ordered more epoxy because I needed the more resin for these joints, because I just ran out of, that one over there, which is good stuff, by the way, but I still needed more. So now we're basically just waiting for ESCs, a couple more motors, a flight controller. I need 2 bus bars that can handle 600 amps, which I did find. The voltage is close enough. As long as it can handle the amps, we're good. What else? ESC. Oh, then the flight controller is obviously a Maytech. We're going to go with that. We're using Drone Can. This is an 18 cell system, so we are using an 18S pack, which is 3 10,000 milliamp Z120C batteries. Uh-oh, it's running out of juice. Got to charge it. Everything's internal now, so that was the whole point of this. Buck converter, bus bar system, all the internal wiring. I've got 2 more sets of wires. Where did I put them? They're over here. Oh, here they are. I've got 2 more sets of the LEDs. These are going to go into the body all the way around. And you tell me that charged or it's got a problem? Looks like it charged. Not bad. Not too snazzy. I had a problem with this bit. Really, Colt? It's gonna lay right there? Okay, let's unplug this thing. Alright. Got the battery. You just gonna lay right there, dude? I would have locked the garage door and didn't even know you were in here. You gotta get on your bed in the house. Alright, well, he will eventually. See if I can plug this back in. One-handed. Probably not. Maybe, hopefully. Can I? Oh, we're getting there. There we go. Nope. Yes. No. Yes. No. Yeah, okay, yeah. Well, at least it'll be a funny video. One way or the other. Anyway. Oh, man, my allergies. Excuse me. So, duct work for this is done. Obviously, for this last engine. We tested this, so these lights are actually working like they're supposed to. I'm just gonna slap the ductwork on it tomorrow. Let it the RTV cure between the pieces. And I used RTV so I could take it apart. Remove a couple bolts up here, take the back end off so I could pull the engine section out if I needed to. This is gonna be a fun experiment because once everything does come in, we are going to be dealing with programming it, programming the ESCs, programming the flight controller. INAV to the rescue for me on this one. Never used drone can before, so that's going to be something that's new for me. And those are on the MAD Components 120 amp 18S ESCs. And yes, for those who might be seeing this for the first time, this over 340 millimeter 11 blade variable pitch high pass, varied pitch, not variable. Sorry, I know people will correct me on that one. The shorties are to cool off the heat sinks that sit underneath the motor mount. That helps keep the engine cooler as things are running. There will be other adaptations to that, including Peltier technology to help cool things down and refrigerate this heatsink with those 12-volt Peltiers. And then the hot side will be cooled by the fan. And that will bring the temperature of this whole top part of the outrunner down, which will help with overheating. I haven't had much problem with the overheating, except when I was testing it with 48 volts, which is what I was doing with this 150 amp ESC. Testing at 48, but it's a 75 volt motor. And believe it or not, you can get overheats because of not using the recommended voltage. If you're using the voltage lower than what this can handle, it can cause temperature spikes. So by using the new 18S ESCs, will effectively be getting it into its power range. It'll take less power, less amps to actually spin the motor up, which is going to be really good. So you got to run it at the right voltage. I was using it for structural integrity tests and balance stuff, so we're good to go there. And then, of course, you know, we're going to do it with the rest of them, make sure everything's balanced. Everything looks good so far. And now we have this last fan, which has basically got its bearings and its lights in place. We'll put the ductwork on it, and then we'll get everything spun up. The idea is that by, if not the end of this month, or close to the middle of it, that everything is assembled, done on the floor, because I'll have to move this cart again, get it back on the floor, get all the pods together, put my carbon fiber rods in across, and then set my plates up for my power pack, and the control deck, all that other good stuff. And a little bit more printing to do above the control deck to hold the ELRS antenna. I am using Radio Master. I'll be running the Radio Master TX16S, which is hiding right behind here, so that I can run the whole drone and change the lighting on the fly. So during the first hover, the maiden hover, we'll be running stabilized. The degrees will be dropped down to like 15, so it doesn't have to, so I don't accidentally like ram it into something. This is going to be hovering in my backyard, not too high off the ground, 10, 15 feet, maybe 20 feet to above the house. I want to get past the ground wash because we are moving a ton of air with fans this size. And at 12,000 RPMs, which is the maximum, we should get stable hover at 4.5 to 5, which is what I'm looking for. When we have that many RPMs to work with, we'll be really, really conservative on the throttle, especially since we are using a completely 3D printed system, which we know from previous spin-ups on the bucket, we know this engine works. If you check out the shorts, if that's even possible, because I don't know if there's something wrong with them right now or what, but there's been a couple reported issues. They said they fixed it, but I think they got another issue going on right now. So I wanted to put this in a longer run video for you guys, so you can see where I'm at, where we're going, and what the next steps are. So ESCs, get that motor put together, get the motors, get my carbon fiber rods in place, mount the motors, get these pods all epoxied together after I get the carbon fiber rods in, and then basically do the same, to the other two over there, to each section of the motor pod I did here, which was an epoxy and then a fiberglass wrap and more epoxy to make sure everything's stable, and reinforce with epoxy and fiberglass where I need to, where I think structurally it needs to be more, stable, more sound. Other than that, vibration mitigation should be okay, because we do have dampening agents in the actual internal hub bearings here. And we have a vertical bearing here. It's actually a tapered roller bearing. So if any major forces are going to be pulling forward, it's going to keep that fan on the vertical. That's what we want. So that's why it's designed that way. Each one has a tapered roller bearing so that it can pull on that motor if it wants to, but it's not going to pull very far because that bearing's there and the shaft is all one piece now. And that will take the torque away from the actual motor shaft and any damage that it might do to the bearings from that forward pull that's happening on the fan. It is my intention in the future to alloy these blades, alloy the hub, alloy the main shaft. I just got to get a 5-axis CNC to get it done. And then the motor mount, of course, and the main stator hub. The rest of this can stay carbon fiber or PETG. That would be totally fine. But the main drive system is cool. Now this is an interesting drive system. If I have a fan failure, I can't home nasally. I'm sorry. If I have a fan failure, what's going to happen is we are going to cut the shaft. I'm going to pull it out, and I'm going to basically replace it with the milled version. So I'm going to be working with a company to get these all milled out, and they'll be lighter weight because it's going to be out of 7075, because that central hub's pretty heavy, because I had to make it solid, and sort of solid. I had to use a gyroidal infill in a lot of walls just to make sure that everything stayed in place, but it still had that sort of spongy kind of, I can flex a little bit effect. But alloy is where we're going with this. Seems like a little early to be planning version 2, but I already have V2 of this drone is going to be black carbon fiber. We're still going to have the lights in there, but we're going to put more of a red feel to it, the black and red, kind of ominous feel. And it's going to be carbon fiber PETG black because it comes out beautiful. It just does. And then this part here will be alloyed along with the rest of the main shaft and the main blade and everything else. I'm also going to do away with the internal 40 bore bearings that I have in here and do 2 tapered roller bearings front and back, which can only be really accomplished if this is alloyed because of the distance between the 2 bearings. But that will also make it to where I do not have to have this upper bearing here for bank stabilization to make sure the fan stays where it's supposed to. Because remember, this is a big 3D printed piece, and while it has bearings in it, it's still going to flex and it's still going to move. It's still going to stretch under the centrifugal force of the blade. Is going to cause some creep in the PETG, especially at higher RPMs. So, yeah. Eventually, the idea is alloyed motor mount, alloyed hub, alloyed shaft, blade, hubs, the whole 9 yards back here. And then carbon fiber, hopefully, for this part here. Something a little bit more stable to keep it nice and tight. And then carbon fiber PETG ducting which will look really good. And version 2 is going to have a lot more accessories in it. So this is basically a flight worthiness test of the entire design. So that's where we're sitting right now. Now we just got to button this engine up, start slapping everything together. Hope you enjoyed the video. I don't know what's going on with the shorts. It's what I usually use to keep you guys updated. But I kind of wanted to go ahead and let's just draw this out and just talk to everybody about what we're doing. So I hope you enjoyed the video. Not going to have a dramatic entrance. Not going to have a dramatic exit. Just a straight, simple video on building a drone with one printer that is well outside the realm of sanity. But fun, nonetheless. So thanks for watching. Hope you enjoyed it. Hope YouTube fixes whatever's going on soon. And I hope to see you all in the next one. Have a good night.